following program is rated G. It is suitable for all audiences.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
So first we will then perform the Laplace transform of 1. Laplace transform of 1 is equal to the integral of 1 times e raised to negative st dt. So here e raised to negative st is also called the cardinal transformation. So we're going to integrate this from 0 to infinity. So let's perform. The integral of e raised to negative st is negative 1 over s times e raised to negative st. So we will take the limit of this from 0 to a very large number, which is, let's call a. So a is our limit is as t approaches infinity. So next we will take the limit and substitute it to the value of t. So negative 1 over s times e raised to negative s times a minus negative 1 over s times e raised to negative s times 0. So here, we will notice that the a, which is approximately equal to infinity, is multiplied to the negative s. So this is just equal to, the concept is just like 1 over a very large number. So this is equal to 0. So let's just cancel this. So next, negative times negative, so positive. So simplify 1 over s times e raised to negative s times 0 is equal to 0. So e raised to 0 is 1. So this is equal to 1. So we come up to the solution that the Laplace transform of 1 is equal to 1 over s. So now let's take the Laplace transform of t. So the Laplace transform of t will be just equal to the integral of the t times the particular transformation, which is e raised to negative st, multiplied by dt from 0 to infinity. So as we notice here, this integral can be solved by integration by parts. So we already know that the formula for integration by parts is just integration of u dv is equal to uv minus integration of v du. So let's name or let's substitute for u. So our u here will become rt, so du will become dt, dv is equal to negative s, dv is equal to e raised to negative st. So our v here will become negative 1 over s times e raised to negative st. So let's perform our integration by parts. So u times v. So first of all, negative t times e raised to negative st over s. So since this is a definite integral, we will take the limit from 0 to infinity. So minus integration of v du. So v times du. So minus integration of v, which is negative 1 over s, and this is negative st, multiplied by du. So dt from 0 to infinity. So as we notice here, we will take the limit from 0 to infinity, so upper limit minus lower limit. So if we substitute infinity here, since as we discussed in the previous Laplace transform, if a number is raised to an infinitely small number, that will just become 0. So our upper limit will become 0 minus lower limit. So 0 substituted to t will become 0 times all the variable here will just become 0. So upper limit minus lower limit will just become 0. So this term will just cancel out, so leaving us negative times negative. So this term will become positive. So this will just become integration of. So let's take out the constant. So this will become 1 over s times the integral of e raised to negative st dt from 0 to infinity. So we already know that the integral of e raised to negative st dt from 0 to infinity is just equal to 1 over s. So this will become 1 over s. So the Laplace transform of t will become 1 over s times 1 over s, which is equal to 1 over s squared. So here we solve that the Laplace transform of t is equal to 1 over s squared. So now we're going to compute for the Laplace transform of t raised to n. So the Laplace transform of t raised to n is equal to integral of t raised to n times e raised to negative st dt from 0 to infinity. So now we will continue to the integration by parts. So let u equal to t raised to n, our du will be equal to n times t raised to n minus 1 dt. Now dv will be equal to t raised to negative st dt, and rv will be equal to negative 1 over s times t raised to negative st. So substitute to the formula of IBP, uv minus integration of v du. So uv over s. We will take the limit from 0 to infinity because it is a definite integral minus the integration of v du. So again, from 0 to infinity times negative n times t raised to n minus 1 times t raised to negative st over s dt. So this term will just cancel out because if you take this, in computing this is upper limit minus lower limit. So first, if we substitute infinity to the t here, it will become e raised to negative infinity. So e raised to negative infinity is just equal to 0. So our upper limit is 0. So minus lower limit. So our lower limit is 0. When we substitute 0 to this t, this term will become 0. So our lower limit is 0. So this term, 0 minus 0 is equal to 0. So this term will just cancel out. So now, we will just take out the constant n over s. This negative sign will just be positive. So this will become integral of this is n over s times the integral of t raised to n minus 1 times e raised to negative st dt. So now we will compute again for the integration by parts of this term. So let u